Behind almost every piece of AI we use today, from the assistant on your phone to incredible medical diagnostics, are the ideas of two key pioneers. And believe it or not, their entire massive contribution can be summed up in just one sentence. It's from a formal award citation, and we're going to unpack that single sentence to tell the story of a technological revolution. And there it is, foundational discoveries, enabling machine learning with artificial neural networks. Yeah, I know it sounds like a real mouthful of technical jargon, right? But here's the thing. Think of it less like a sentence and more like a formula. Each part of this phrase is a key ingredient that, when you put them all together, literally change the world. So let's break down that formula. That is the big question, isn't it? It's kind of a puzzle, and we're going to solve it together, piece by piece. I promise, by the time we're done, that dense sentence won't just make sense. You'll see how it's basically the blueprint for the entire modern age of AI. All right, so every great story has its main characters. In the story of modern AI, that award citation points us directly to two key figures. These are the people whose work laid the foundation for everything, and I mean everything, that came next. So, who are we talking about? Meet John J. Hopfield and Geoffrey Hinton. The award celebrates them for their foundational contributions. And to give you an analogy, think of it this way. They weren't just brilliant architects designing a cool new skyscraper. No, they were the ones who actually invented the steel and the concrete, the very materials that made building modern skyscrapers possible in the first place. So, we've got our pioneers. Now, what was this revolutionary engine they helped create? Well, that brings us to the next core concept right from the citation: artificial neural networks. The core idea here is actually brilliantly simple. It's, what if we built a computer system that was inspired by the human brain? So instead of rigid, step-by-step instructions, an artificial neural network creates this web of connections, kind of like digital neurons, that can learn, adapt, and spot patterns all on its own. And how does this digital brain actually work? Well, at its simplest, it's a three-step process you can see right here. First, the input layer acts like our senses. It just takes in all the information. Second, the hidden layers, this is where the real magic happens. This is the processing, the connecting, the thinking part. And finally, the output layer gives you the result. This layered structure is the absolute key to its ability to learn. Okay, so we have the pioneers, and we have their brain-inspired technology. But what was their specific stroke of genius? That citation gives us two really important clues: discoveries and inventions. Let's pull those two apart for a second. First up, discoveries. I want you to think of these as the big eureka moments. At this stage, they weren't building things just yet. They were figuring out the fundamental laws of this whole new universe. They were asking the really big questions, like, how could these networks even work? How could they store memories? How could they possibly learn? These were the conceptual breakthroughs that completely changed the game. But, big ideas are one thing. The citation also credits them with inventions. And this is the other crucial half of the story. They took those abstract theories and forged them into practical tools, the actual algorithms and methods that engineers could use to build real-world systems. So they didn't just write the physics, they built the engine. So what happens when you combine these pioneers, their groundbreaking discoveries, and their practical inventions? Well, you unlock the ultimate goal, the huge payoff mentioned right there in the citation. You enable machine learning. And this is the total game changer. Machine learning is what allows a computer to look at, say, thousands of cat photos and figure out for itself what a cat looks like, without a human having to program if it has pointy ears and whiskers, then it's a cat. The discoveries and inventions of Hopfield and Hinton provided the essential foundation that makes this incredible kind of learning possible. All right, we've broken the whole puzzle down. We've looked at all the different pieces: the pioneers, the core concept, the breakthroughs, and the amazing results. Now, let's put it all back together and look at that original sentence with fresh eyes. See how it just reads differently now? For foundational discoveries and inventions, those are the core ideas and the practical tools they built that enable machine learning. That's the powerful outcome of all their work with artificial neural networks, the brain-inspired system they helped create. It's not just a string of technical words anymore. It's the story of a revolution. Ultimately, the work of Hopfield and Hinton didn't just give us better computers. It gave us computers that can actually learn. They fundamentally changed our entire relationship with technology. And that leaves us with one really profound question. Now that we have machines with this incredible new ability, What are we going to teach them next?